Barun Aggarwal, the founder and CEO of BreatheEasy Consultants Private Limited. He has co-authored a book, How to Grow Fresh Air. He serves on many national and international boards and committees to create standards and policies around air quality, including ISHRAE, IAQA, USGBC, and IGBC. Mr. Barun is a climate reality leader trained by the Vice President Al Gore. As a visiting faculty, he teaches a course on human wellness in the built environment at the School of Planning and Architecture, New Delhi. Today, Mr. Barun will talk about how automation optimizes resources for better air quality.
Essentially, we're going to talk a little bit about automation and understand how we can optimize our resources and still achieve perfect air quality. Energy is the next gold, right? We talk about energy conservation. We talk about getting to a state of net zero by 2070, as the Prime Minister has already announced. And everything that we need to do as a nation is to align our vision and our goals to achieve what our Prime Minister has announced with regards to 2017 being carbon neutral. So this is the first step towards that. So just very quickly want to talk about a competition that was set out by the Asian Development Bank to design a disease-resilient, energy-efficient central air conditioning system. It was a global challenge, and we put together a team called Team Parivartan, and we won that global challenge by the Asian Development Bank, and we've put together trial projects now, which are very successfully running with regards to disease resilience and with regards to energy conservation with central air conditioning systems. So just in terms of what it looks like, so we've upgraded HVAC systems, we've enhanced the ventilation and monitoring, we've put in enhanced indoor air quality systems and smart controls with a dashboard, which gives us the optimization capability for the entire system and the automation that is required, because we know that human beings are prone to a lot of errors. So how do you automate this as much as possible and optimize the solution is what we were looking at. So just quickly, we've got energy efficiency of close to 30% lower energy annually with our systems. We are using low GWP refrigerants, which are climate friendly. We are completely disease resilient. The transmission risk of viruses within our facilities is measured by a team of experts contracted by ADB and to be less than 95% compared to other facilities. And the information technology that we've used to automate and optimize is what I think we'll start seeing in the future. So this is a picture of that facility, actually, just one small picture of what it looks like. But the readings that we were getting were readings of 0 AQI and 0 micrograms inside the office. We don't talk about 50, we don't talk about 40. For me, the goal is 0. In fact, we have a new company that we've registered called Zero AQI Technologies, because my goal is to give 0 particulate matter and 0 AQI within facilities, because if we can reduce the particulate pollution that is going into our lungs down to 0, then only will we genuinely live a healthy life. And I say 0 is important because up until last year, the World Health Organization had said that the annual average exposure level needs to be at about 12 micrograms per cubic meter. And this year, they've reduced that limit down to 7 micrograms and saying that if we reduce it by just that much, we will save nearly 5 or 7 million lives around the planet. So that's the kind of impact that even a small amount of particulate matter has on our lungs and on our health. Outdoors in Delhi and in northern India, we see readings of 300, 400, 500 in the winter times very frequently. And even on those days, we are able to achieve 0 micrograms indoors in our facilities. So you can't manage what you can't measure, right? Said Peter Drucker. And making the invisible visible is what we do. So you got to measure it. And that's how you can make what is invisible, i.e. the pollution in the air, visible. So we measure key IAQ parameters, and thank you, Mr. Prashant, for your presentation on Fluke. We use a lot of Fluke products with regards to our testing capabilities that we have. We have a laboratory that tests for different air quality parameters, not just air quality, but environmental parameters, including light and sound and other occupancy parameters that we have. So we use artificial intelligence and machine learning also to optimize our systems for better occupant health. I was part of the ISHRAE COVID-19 guidance document for air conditioning and ventilation. And when we were writing that document, 5 main pillars came out with regards to managing COVID within spaces. One of them is ventilation, one of the most important things, which is very common in India, but we sometimes in air-conditioned spaces, we forget to add the right kind of ventilation. The second one is the right kind of filtration. And then the third was the right amount of flow or draft of the air, which you can measure with a Fluke equipment or any other similar kind of equipment. And then you've got the temperature and the relative humidity. So those are the 5 main pillars when it comes to COVID management within facilities. And we added disinfection in there because that sometimes is important, but it depends how you do your disinfections. It's more important in isolation areas in cases of COVID patients. So the best practices for healthy IEQ are essentially design and remediate, continuous monitoring and managing what you've done, because air quality is something which is constant and dynamic. If you're not constantly maintaining what is going on within your facilities, you are not going to be able to achieve and maintain what you need in terms of indoor environment and in terms of health outcomes. So managing what you have implemented is very key. And for that, automation and we'll see a little bit in the next few slides in terms of automatic notifications that go out to us when anything goes wrong within a facility, and that becomes very important and valuable. So monitoring reveals the big picture, right? Or a time trend versus a spot reading. It tells us what's going on within a space over a long period of time and tells you what the big picture is, what are the trends. And you can sometimes understand the nuances of a facility very easily, such that you're able to save huge amounts of money because you turned on your chiller or your central air conditioning 1 hour too early, or you didn't realize it and you turned it on at a certain time, whereas you could have very easily turned it on 1 hour later and still achieve the same end user result. And those trends is something that you can start to analyze with monitoring. Increased range of sensors, air quality sensors are particulate matter, chemical off-gassing with TVOCs, carbon dioxide, carbon monoxide, and then there's a whole bunch of others in terms of formaldehyde, nitrogen dioxide, ozone, sulfur dioxide, hydrogen sulfide. We can test for 300 different gases and then target that specific gas depending on the kind of filter that we use to ensure that the right result is achieved from a human comfort perspective. From comfort perspective, we've got relative humidity, temperature, light intensity, color, temperature, and noise. We are measuring energy and gas and water usage is coming up in our dashboard. And health, we're measuring absenteeism and movement and fitness. It hasn't yet been added to our dashboard, but it should be coming in sometime soon. So the 5 key IAQ parameters are PM 2.5, TVOCs, carbon dioxide, relative humidity, and temperature. And these are the basis of some of the standards that are being created around the world, like the reset standard for indoor air quality is based on these 5 key IAQ parameters. And within monitors, you've got an A grade, B grade, and a C grade monitor. C is consumer grade, B is commercial grade, and A is a reference grade or research grade monitors. And an example of a B grade sensor is what you see on the screen over here. These have all 5 parameters of IAQ, i.e. temperature, humidity, carbon dioxide, CO2, and TVOCs. Both of these, one from Ayurveda, one from Kythera, they're different price points, different look. We integrate these into our dashboards and we implement them for all our clients when we implemented a complete turnkey solution for indoor air quality for them. The services don't end after installation. This is a very key point because when you're looking at optimization, it's not just about initial installation of your systems. You've got to ensure that you're achieving optimal results on an ongoing basis. If I put in a system that I can tell you that can guarantee 20% reduction in energy, but I don't maintain that over a period of time, then you're not going to achieve the 20% reduction in energy. And what value is that to you if I've just installed it and forgotten about it? So very important to offer services to your clients and ensure that they're getting the value that you have promised them. There are monitor installation standards, which are also important in terms of knowing where to install your monitors. Deployment locations will depend what you're measuring, where you're measuring. So depending on different kinds of facilities, you would put your sensors in the different places so that you're measuring correctly in terms of the occupant comfort as well as the owner's requirement of what he wants to do. So the key areas of focus really in a facility are data analysis, or ensure that automation is working well, indoor-outdoor displays. So we've done a lot of displays for our clients so that they're real-time displays. When you go into good quality facilities which have measurement capable or filtration capabilities, they initially are scared of displaying those results to their customers because they're not sure of the results. But over a period of time, when there is confidence that yes, we've done a good job and the results are good, they want to get on top of their buildings and scream to the world that we've done a great job. And that's when they put their displays and want to tell the whole world that, look, this is the air quality that we have in our building. And at the end, we also get certification, whether it's an IGBC or a USGBC or a reset certification. We have APs on our team for all of them, and we can get you certification for your buildings with regards to green buildings and air quality certifications as well. So just a couple of screenshots in terms of what the dashboard looks like. So you've got a bird's eye view of the whole system. If you have multiple facilities, you can have multiple floors. So this is an example of a particular school, ground floor, first floor, second floor, third floor, fourth floor. Every single classroom has a monitor, and we're monitoring that in real time. We get email and mobile notifications. So if there's anything wrong in any particular facilities, you can immediately get an SMS, and then somebody in the maintenance can go and take a look and see what's going on. You can edit your alerts for different monitors, and then you've got the different standards in terms of the reset air standard. ISHRAE, I was part of the IEQ standard of ISHRAE as well, on the committee that created that standard. I've been part of the reset and the well standards as well, and also the USGBC lead standard 4.1. I was on the indoor air quality assessment working group for USGBC as well. So been fortunate to be part of multiple standards committees around the world, and these are literally cutting edge technologies and standards that are being created with regards to indoor air quality and indoor environmental quality today. You can benchmark and compare your results with different floors, different facilities using the dashboard. You can do an overall floor comparison in terms of what is going on. And this is probably one of the most important ones in terms of on-demand automation and system improvement. So with machine learning, we are able to figure out how on demand we are able to understand what is the requirements of the system, what is the occupancy is being measured automatically, and based on the occupancy, what is the demand on the system in terms of CO2, what is depending on the different levels of CO2 we are measuring at different points within the HVAC system, within the occupied spaces. So lots of sensors are being used across the board to automate and starting to use machine learning, because the logic that we started to put in initially was not enough to optimize the facilities. So machine learning became a very important part of what we started to do, and we realized that machines are in fact smarter than human beings, and they're able to optimize the solution a little bit better than what we were able to do manually. We found a lot of errors, prone to a lot of errors when it was manually managed, but as we've started to automate it, it's become a lot easier. So this is an example with automated versus manual operation. So you can see here, what is the result of particulate matter when it was manually managed, the graph on top, whereas when it was automated, this is the graph at the bottom. So automatically you're getting much better results in terms of particulate matter within the facility when you did automation versus manual operation. So displays that we've done in multiple facilities around the country. We've got close to 10,000 customers today. So it's hard for me to list out a list of all my customers. But we've worked with 10,000 customers in the last 8 years of working in the space of indoor air quality and energy efficiency. We've got animation displays as well in terms of what's indoor versus outdoors, what percentage of air is better, what is the percentage that your air is better indoors versus outdoors is what we are telling our customers. So automation has played a very key and important role for us, and that is what I wanted to share, and be happy to take any questions from you.